Welcome to the CCNA 1 version 7 module 8 to 10 exam review. In this section, I will cover exam questions related to communication between networks. These questions are from real past exams. However, all questions and answers will be randomized by Cisco and you may or may not get the same questions during your exam. Please keep in mind that I have already covered the CCNA 1 lectures in my lecture series that are already posted on my YouTube channel. I already have covered CCNA 2 and CCNA 3 as well. So if you are interested in learning about concepts that may be covered in this section of exam review for CCNA 1, I recommend that you go back to my CCNA 1 Introduction to Network lecture series and watch those. If you have any questions or concerns regarding any of the exam questions that I have covered in this video, you feel free to contact me by leaving a comment below, or you can reach out to me by sending an email. So let's look at our question number 1. Which IPv4 address can a host use to ping the loopback interface? In other words, the Cisco is asking what is the loopback interface IP address? So we have options of 126.0.0.127.0.0.0, 126.0.0.0, and 127.0.0.1. Now, in this situation, what you need to remember is that you need to know what is a loopback IP address. So I will give you a couple of seconds to think about this, because this should be something in your back of your mind and it should be an easy answer. The loopback IP address is the 127.0.1. And keep in mind that the loopback is the routing of electronic signal or digital data streams back to the source without any internal processing or module modification, right? So what that means is loopback is basically used in terms of like testing the communications interfaces by like pinging itself. In TCP IP model, our loopback address always going to be 127.0.0.1, so 127.0.0.1 in the IPv4 configuration, and the ranges for loopback addresses can start from 127.0.0.0 and ends with 127.255.255.255. So generally, when we talk about a loopback interface IP address, it's always going to be 127 range, and it always going to be typically 127.0.0.1. Now, if you go to an end device or even intermediary device, and if you start testing this loopback address, you can ping the 127 subnet, that IP range, by entering 127.0.0.0. But however, if you ping 127.0.0.0, what will happen? It'll end up with an error message saying general failure. The reason for that is you also need to remember for your Cisco exams that 127.0.0 is the network address that is reserved for network address in the loopback IP address range. And if you ping anything else in that 127 IP address range, for example, my loopback address of 127.0.1, it should give you a reply back if your TCP IP stack is working on your device. If this come up back with an error message, that means something wrong with your TCP IP stack on your device that you're testing. But notice I can also ping 127.0.0.55, 66, 57, 10, 11, etc., etc., all the way to .255.255.255. So you can have all of these things filled at 255. And that will also give you a loopback reply if your TCP IP stack on your device is working. So that's what you need to understand with respect to loopback interface. In terms of as far as writing the exam and trying to save some time on some of the question, you could also just memorize that 127.0.0.1 is what we typically use as the loopback interface IP address, also known as the local host. This is also sometimes known as the local host. So the Cisco could ask which IP address can be used as the local host, and that could be 127.0.0.1. So again, the IP address that is on the loopback interface is not always going to be .1. It could be any IP address between 127.0.0.1 to 127.255.255.255, because you could fill out all of these octet with 127 after 127 all the way up to 255. But 127.0.0.0 going to be our network address, and that's why you cannot ping that. So we'll go to the next question. Question number 2. What routing table entry has a next hop address associated with a destination network? What routing table entry has a next hop address associated with a destination network? Directly connected routes, local routes, remote routes, C and L source routes. So you need to think about, when do we need the next hop address? Well, typically this should be an easy question if you understand how routing protocols work, which I'm not going to go into depth. If you understand why we need the next hop address, it would be an easy answer. So I'll give you a couple of seconds to think about that. So the answer to this question is the remote routes, because that's when we need the next hop address. Question number 3. What is a basic characteristic of the IP protocol? Connectionless, media-dependent user data segmentation, reliable end-to-end delivery. So you need to look it from the internet protocol point of view, because that's what the IP protocol is. So what it's asking is, what is a basic characteristic of that IP protocol? Again, this is a fundamental question. I'll give you the answer in a few seconds. So the internet protocol, also known as IP, is a network layer protocol that does not require initial exchange of any control information to establish an end-to-end connection before that packet's been forwarded, right? So what does that translate into is that mean you can communicate in an IP protocol connectionless. You don't need to have any initial exchange of control information in order to exchange information within an IP protocol method, right? So thus the IP is basically connectionless and does not provide reliable end-to-end delivery itself, but it can be modified in a certain way that will allow reliable delivery, which we can discuss later sometime, or you can watch my CCNA lecture series. So the answer to this question is connectionless. Question number 4. Which term describe a field in the IPv4 packet header used to detect corruption in the IPv4 header? So what term do we use to describe a field in IPv4 packet that will detect a corruption in the IPv4 packet itself? So the answers could be header checksum, source IPv4 address protocol, or TTL, which stand for time to live, which you should be familiar with. I'll give you a few seconds to think about it. Again, this is a very easy question if you understand how IPv4 header works. So the answer to this question is the header checksum. you need to know the different sections of your IPv4 header and your IPv6 header. Otherwise, you won't be able to answer this question, and you need to understand what those those sections do. If you forget the answer to this question, one of the easiest way this is the answer is a checksum. So typically checksums are associated with error detection. So error detection can be used for corruption detection as well. So therefore the answer to this question is checksum if you know nothing about the IPv4 header. However, for your CCNA 1 exams, you should know your IPv4 and IPv6 headers like back of your hand. So if you look at the IPv4 header, there are different sections on that header, right? And IPv6 also has different sections. So I've taken this image out of Cisco exam study materials, and you can see certain sections between the IPv4 and IPv6 they share. For example, source address, destination address, both IPv4 and IPv6 need it. But however, certain sections we don't have it in IPv4, such as this new field in green, for example, flow label is not part of the IPv4 header. So you need to know what each one of these things do. If you look at your IPv4 header, you can see we have a header checksum right here, and that is what we can use to detect errors and corrupt packets in the IPv4 stream. So you need to understand how IPv4 header is different from IPv6 header, and you also need to understand the different sections of IPv4 and IPv6 headers and understand each one of these things do. Worst case scenario for your exams, just memorize this, and you should be at least have a basic idea about how this IPv4 and IPv6 headers work. But in generally, you need to understand all of these sections. So if you want to pause this video and take a quick look at this, go ahead and do that. And we will move on to the next question. Question number 5. Which information is used by routers to forward a data packet towards its destination? So what information is used by a router to forward something to its destination, right? So in routers, forward what? The packets, right? So that's the question is asking for. We have source IP address, destination IP address, source data link address, and destination data link address. This is a very easy question because of the answers are provided here, because it doesn't even mention MAC addresses, etc., right? So which information is used by routers to forward data packets to its destination? So the answer has to be either destination IP address or destination data link address. So this answer should be the destination IP address. This is a very easy question. Very easy question. I don't even give you time to think about it. This is the answer. Destination IP address. Question number 6. What property of ARP causes the NICs receiving an ARP request to pass the data portion of the Ethernet frame to the ARP process? Right away, you need to know what is ARP, and you need to know how NICs behave with respect to ARP. So ARP stands for Address Resolution Protocol. It is a protocol or procedure, in other words, that use the IP space, Internet Protocol Addressing System, that allow communication between different devices using MAC address and bunch of other stuff, right? So you need to understand at least how the ARP process works to answer this question. And what it's asking is what causes that ARP, what causes that the NICs receiving that ARP request to pass that portion of the Ethernet frame to the ARP process. So the answers includes the type field 0x806 appears in the header of the Ethernet frame. The destination MAC address have all Fs appeared in the header of the Ethernet frame. Entries in an ARP table are timestamp and are purged after the timeout expires. The ARP replies are broadcast on the network when a host receives an ARP request. So to answer this question, you need to understand the lectures associated with the Cisco CCNA 1 program. Otherwise, this is going to be a difficult question for you to answer. Not only you need to understand what is ARP, what is NIC, but you also need to understand all these concepts associated with the answers in here. So I'll give you a couple of seconds to think about it. Again, if you don't understand the fundamentals of ARP, you probably won't be able to answer this question. So the answer to this question is the type field 0x806 appear in the header of the Ethernet frame. That is the answer. And why this is the answer? Go back to your ARP notes and check the notes, then you will understand why this is the answer. And if you couldn't get it, check my YouTube videos that I have already posted on CCNA 1 lectures. It's a little bit of a tricky, difficult question if you don't understand how ARP works. Question number 7. What happens when the transport input SSH command is entered in the switch VTY lines? So what happens when you enter the transport input SSH, this part, transport input SSH. I should have like bolded this or italicized this, but this is the part we are entering on your Cisco device, transport input SSH command, but on the switch VTY lines. So the answers include the SSH client on the switch is enabled, communication between the switch and the remote is encrypted, the switch requires username and password combination for remote access. The switch requires remote connections via a proprietary client software. So what happened on a Cisco switch if you enter transport input SSH? I'll give you a couple of seconds to think about it. So the transport input SSH command is enter on the switch where VTY line, which is VTY stand for what? VTY is the virtual terminal lines. That's what the VTY stand for, virtual terminal lines. What that will do is basically going to encrypt the data that goes through the switch remote user, right? So the answer to this question is the communication between the switch and the remote user is now encrypted after you put the transport input SSH as a result of that command on Cisco switches. So that's the answer to that question. Question number 8. A router boots and enters setup mode. What is the reason for this? So you have a router, you boot it up, instead of it's actually doing what you expect it to do, maybe going into some configuration mode, but it goes into a setup mode. The answers include the iOS image is corrupt, the Cisco iOS is missing from flash memory, the configuration file is missing from the NVRAM, the post process has detected hardware failure. Remember, there's a post process, power on self-test process on every Cisco device. So it detected the hardware failure. So what causes a router to boot and enter into a setup mode? I'll let you think about this for a second. I'll give you a hint if you don't remember. You need to think about Cisco bootstrap sequence. You need to memorize Cisco bootstrap sequence if you don't understand how the bootstrap sequences work. It's not just unique to Cisco. Some Linux and Unix machines also does this bootstrap sequence a similar way. You need to remember with respect to Cisco bootstrap sequence, what is it doing? So why would a Cisco router boots into a setup mode? So I will give you the answer. The answer is the reason why it does that because the configuration file is missing from the NVRAM. If the configuration file is not there, the Cisco routers will always boot into the setup mode. Why is this? Because if you look at how Cisco bootstrap sequence work, we have post and then we have the bootstrap right after that. And then after that, the Cisco iOS start loading once the bootstrap has been completed. In the bootstrap, we load the bootstrap files, and that get loaded from the ROM. But the Cisco IOS get located in the flash and the TFTP, and then the configuration files are get loaded from the NVRAM. Now the question is asking, the router boots and enter into a setup mode. Well, if the configuration file from the NVRAM is missing, what happened is at this point, if the NVRAM is missing, it goes back into the setup mode as a result of this. You need to understand this sequence like back of your hand in order to do well, not only on your Cisco lecture exams, but also on your lab exams. I took this diagram directly out of your Cisco CCNA 1 notes and lecture support that is available also on the cisco.com website. And you need to understand this concept of post all the way to configuration and what are the breakdown and what happen if at any point this thing fails. So the answer to that question is basically that router directly boots into the setup mode. That means the configuration file is missing from the NVRAM, and that's why it goes into that mode. Question number 9. Which term describes a field in the IPv4 packet header that contains an 8-bit binary value used to determine the property of each packet? So we are looking for a term that will describe an IPv4. Remember, we are not looking at IPv6 yet in here. We are looking at IPv4 packet header that contains 8-bit binary value that will determine the priority of the packet. Differentiated services, destination IPv4 address, source IPv4 address, and protocol. Again, this should be an easy answer just by reading the answers below. I'll give you a few minutes to think about it. So we can already eliminate the destination IPv4 and source IPv4 address. So it has to be differentiated services or protocol. And the answer to this question is the differentiated services. The reason for that is originally in IPv4, only first 3 bits were used for QoS values called IP precedence. Remember, for quality of services, we used 3 bits originally on IPv4 called the IP precedence. Later, it was superseded by the diffserv technology, which is called diffserv for differentiated services is often described as diffserv in the industry, and that diffserv technology that uses the first 6 bits and value that value we call the differentiated service code point, or DSCP. So the DSCP is part of the diffserv technology that used the first 6 bit of that. So the first 8, so the containing 8-bit binary value in IPv4 header is the diffserv or differentiated services. So that's the answer to question number 9. Question number 10. So we're going to look at an exhibit from a Cisco, a CLI. It's shown here on the right hand side bottom corner, not left, sorry, right hand side bottom corner. So the question is, a network administrator is connecting a new host to the service LAN. So we are connecting a new host to the service LAN. The host needs to communicate with remote networks. What IP address would be configured as the default gateway on the new host? So we are looking at a screenshot of configurations given to you during the exam, and you need to figure out an answer based on that screenshot. So that's why I'm trying to get you here. So on the bottom right hand corner, we have a screenshot of a configuration, and we're asking what IP address would be configured as the default gateway on the new host. So this is basically showing bunch of data, and then it has connect to the service LAN. Oh, look at that. the very first thing it says connect to the service LAN as the description. The next one description says connect to the engineering LAN. The next one says the connect to the ISP, and the next one says the description connect to the head office WAN. Now, in this screenshot of CLI, unless the Cisco specifically gives some other piece of information, you don't know which IP address connect to what. If this description, which is be entered as English text or text, right, by the administrator, network administrator, is incorrect, there's no way you would know that is incorrect unless there's a packet tracer file or something else is provided to you that will give you the answer. So the only way to answer this question number 10 during an exam is just referring to what you already see on the screenshot of the Cisco CLI. So because on the first part of the question says a network administrator is connecting a new host to a service LAN, and they're asking what would be the IP address configured as the default gateway of that host that is connecting to the service LAN. If you look at all the descriptions here, the only one that has service LAN is this very first one. And the IP address is set up in here as 172.29.157.156 and the subnet mask of 255.255.255.0. As a result, the answer of this question going to be the very first answer, which is 172.29.157.156. Again, I'm going to repeat, this is a very important concept. You might think, how does Manuja knows that the service LAN host going to have a default gateway of 172.29.157.156, not 10.156.157.254, for example. The only way I know this without a packet tracer file, without a lab file, is that because they gave a screenshot and they wrote the description saying here that the interface GI01 will be the the interface that is facing the service LAN network, and because we are connecting the device to the service LAN, so the default gateway has to be one underneath under it, so it will be the 172.29.157.156. So that's how you answer this type of question. There are a few questions similar to this later in my lecture, so keep watching. But here's a really good exam question that some people may get confused. Question number 11. What will happen if the default gateway address is incorrectly configured on a host? So, for example, in the previous exam, screenshot, what happened? The CLI have, the system network administrator have entered incorrect default gateway configuration there, or something that is incorrectly entered on the host itself, right? So in this question, it's specifically focusing on the host. So what will happen if the default gateway address is incorrectly configured on a host? The host cannot communicate with other hosts in the local network. The switch will not forward packets initiated by the host. The host will have to use ARP to determine the correct address of the default gateway. The host cannot communicate with hosts in other networks. A pin from the host to 127.0.1 would not be successful. So I'll give you a little bit of time to think about it. So the issue here is the default gateway is not correctly configured in the host, not the router, not the switch, but the host itself is incorrect. So basically manually incorrectly entered default gateway. So if you read the answers, you already can eliminate a couple of these things. Remember, I already discussed the loopback IP address of 127.0.0.1. Remember, that tests the TCP IP stack of your device without having to route any packets through the network, just to test that the TCP IP stack is working on your device. So this can be the answer. Ping from the host to 127.0.0.1 should always be successful if the TCP IP stack is working. It doesn't matter what the gateway address is. So we can eliminate that answer. And then you left with a bunch of other answers, and the answer to this question is the host cannot communicate with host in other networks. It can communicate with the devices within the same network, so it can ping each other. It can communicate against other devices in the same network or same subnet, but it cannot go out and reach, for example, the internet, because it it doesn't have the default gateway. The other way of explaining this is that when a host needs to send a message to another host located on the same network, it can forward that message directly, right, using the MAC addresses, etc. However, when a host needs to send a message to a remote network, it must use the router, because it needs to route that package now. It can't just switch the packet, you need to be routed. And also know that default default gateway address is used to do that. So it is used to communicate between network devices outside the network which the host is part of. So instead of they are communicating with host communicating with devices that are directly connected, they are to the same network. It communicating with devices you could think of as a remotely connected on a different network. So instead, the IP packet, in other words, has to be sent to the router, which is a default gateway, and the router will route or forward the packet towards the destination. So in other words, if the default gateway is incorrectly configured, the host can still communicate with other hosts in the same network, but won't be able to go out and reach to the other devices outside of that network. So that's the answer to that question. Again, I'm providing way too much details for an exam revision or review. If you want to learn more, go and watch my YouTube videos on CCNA 1 lectures. Question number 12. What property of ARP, address resolution protocol, forces all Ethernet NICs to process an ARP request? Again, I already gave you a similar question related to ARP and NICs. I mentioned to you, you need to understand what ARP and how ARP works, and you need to also understand how NICs behave with ARP, how NIC handle ARP request. So ARP stands for address resolution protocol, and they're asking what property of ARP forces all Ethernet NICs to process an ARP request. So the answers include the destination MAC address having all Fs appears in the header of the Ethernet frame. The source MAC address appears in the header of the Ethernet frame. The type field 0x806 appears in the header of the Ethernet frame. The ARP replies are broadcast on the network when the host receives an ARP request. So what would be the answer to this? So this question is slightly different from the question that I asked before about ARP and NICs. So think hard, and what would, based on your knowledge of Cisco CCNA lecture material, what property of ARP will force that Ethernet NICs to process an ARP request? So the answer to this question is the destination MAC address have all Fs appear in the header of the Ethernet frame. It is a unique MAC address that is used in the ARP process that will force all Ethernet NICs to process an ARP request. So that's the answer to that question. Question number 13. What information does the loopback test provide? I have repeated the answer to this question over and over in the past few slides. So past few questions. So this should be an easy answer now. So we are talking about loopback test. So remember loopback IP address 127 dot range IP address. So what information does a loopback test provide? So answers include the device has end-to-end connectivity, the DSCP is working correctly, the TCP IP stack on the device is working correctly, the Ethernet cable is working correctly, the device has the correct IP address on the network. Because I already discussed this few minutes ago, this should be an easy answer. So what does a loopback IP address or loopback test provide? Pinging the loopback IP on a device or host will give you as a network admin? I'll give you a few seconds to think about that. And here's the answer. The loopback IP address or loopback IP ping test will give you a idea about the, give you whether the TCP IP stack on the host itself, the device itself, is working correctly. It's not testing DHCP, it's not testing end-to-end connectivity, it's not testing any network connection. You can even, remove the Ethernet cable and you should still be able to do the TCP IP stack test called the loopback test. It will check the TCP IP stack of your own device. So that's the answer to this question. Question number 14. A computer has to send a packet to a destination host in the same LAN. How will the packet be sent? So this host or computer is not sending the packet outside its own network. It is sending to a host within the same network, same subnet. That's what they're asking, same network, and how will the packet will be sent? So the answers include the packet will be sent to the default gateway first, and then depending on the response from the default gateway, it may be sent to the destination host. The packet will be sent directly to the destination host. The packet will be sent to the default gateway, and then from the default gateway, it will be sent directly to the destination host. So the difference between the first answer and the third answer is that it does not maybe sent to, it will be sent to there. And the last answer is the packet will be sent only to the default gateway, and then the packet may get discarded or something will happen to that packet. I'll give you a couple of minutes to think about it. Again, if you understand your CCNA fundamental concept, this is an easy question to answer. Recall that you need a router to route packets when you are communicating outside your own network. If you are communicating within your own network, do you actually need a router to route your packet? No, you don't. So if you understand how IP protocols work, how IP packet switching works, based on my lectures that I have already posted, the answer is very easy. The packet will be sent directly to the destination host because the packet is traveling within the same network, same area. As a result, it will directly be sent to the destination host. In fact, if the host do not even have the correct gateway IP address, this packet will still get routed because it is within the same network. You don't even need to think about gateway when a computer is sending a packet to another device or computer that is in the same network. So that's the answer to that question. Question number 15. Which two types of IPv6 messages are used in place of ARP for address resolution? Which two types of IPv6 messages are used in place of ARP, address resolution protocol, address resolution? So anycast, broadcast, echo reply, neighbor solicitation, echo request, neighbor advertisement. So we are looking for two answers with respect to IPv6. If you understand IPv6 header and you understand how IPv6 works in terms of address resolution and how IPv6 routing works, this is an easy answer based on the answers given below. I'll give you a few minutes to think about it. So which two types of IPv6 messages are used basically in place of ARP, right? Remember, IPv6 does not use ARP. Instead, what it uses is something called ICMP-v6. So I give you already a hint there. So what does ICMP version 6 has that replaces the processes that we used in ARP methodology in IPv4? So the answer to this question is the neighbor solicitation and neighbor advertisement. neighbor solicitation and neighbor advertisement. So these are the two things that we use in IPv6 in place of ARP that we found in IPv4, right? So you also need to remember that, you know, the neighbor discovery protocol, also known as NDP, or, you know, simply NDP, or the neighbor discovery protocol, that it has 5 ICMP version 6 packets, not just neighbor solicitation and neighbor advertisement. So there's like 5 different types of 5 different types that you need to remember, packets in the ICMP version 6. Those includes the router solicitation, router advertisement, neighbor solicitation, neighbor advertisement, and network redirects. You have to understand what they are for your CCNA exams. This is just a tip of the iceberg. This is a general question. On your final exam, it could be a little bit of a more technical questions that could come up with related to IPv6 replacements for ARP. So remember, IPv6 do not use ARP. Instead, we use ICMP version 6, and it includes router solicitation, router advertisement, neighbor solicitation, neighbor advertisement, and network redirects. You need to remember all of those things for your CCNA exam. For this question, we're simply looking for the 2 ICMP version 6 packets, which are neighbor solicitation and neighbor advertisement, which replaced the ARP for IPv4 6 in IPv6 in this situation. Question number 16. The global configuration command IP default gateway 172.16.100.1 is applied to a switch. What is the effect of this command? So we are in the global configuration mode in the Cisco switch, and we are entering IP default gateway 172.16.100.1. So the answers include: the switch will have a management interface with the address 172.16.100.1. The switch can be remotely managed from a host on another network. The switch can communicate with other hosts on the 172.16.100.0 network. The switch is limited to sending and receiving frames to and from the gateway 172.16.100.1. So I'll give you a little bit of time to think about it. So the explanation here I can give you is that the default gateway address is typically configured on all devices to allow them to communicate beyond just their local network, right? I have been repeating this for the past few minutes. That's why we don't need a router in an internal network, local network communication, but you do need a router that you know how to go outside, right? So in a switch, this can be achieved by assigning a default gateway, because if the switch doesn't know where the default gateway is, it can only send a packet across their own network, right? So the answer to this question is the switch can be remotely managed from a host on another network by giving it a default gateway this way with this command. Because if you don't give this command, you cannot access that switch remotely to manage from a host on another network. So that's the answer to question number 16. Question number 17. What important information is examined in the Ethernet frame header by layer 2 device in order to forward the data onward? So what important information is examined in the Ethernet frame header by a layer 2? This time we are looking at layer 2 device in order to forward the data onward. Source MAC address, source IP address, destination MAC address, Ethernet type, destination IP address. You need to understand what's a layer 2 device is. Layer 3 devices are routers. Layer 2 devices are switches. So how does a switch is different from a router? I already explained this a couple of minutes ago. So we are looking at things like switches where we use what? We use the destination MAC addresses. In layer 2 devices, we forward packets or frames, Ethernet frames, based on the destination MAC address, not the IP addresses of any kind, but the MAC addresses. This is why you can still communicate without routing the packet, basically switching the packet in this situation. Question number 18. Which two functions are primary functions of a router? Which two functions are primary functions of a router? So we need to pick two of them. Packet forwarding, microsegmentation, domain name resolution, path selection, flow control. So out of all of these answers, packet forwarding, microsegmentation, domain name resolution, path selection, and flow control, which are the two primary functions of a router? What does a router does on your network as opposed to a switch or other intermediary devices? I'll give you a few minutes to think about it. So how does a router works? You need to understand that. So a router accepts packets and access its routing table to determine the appropriate exit interface based on the destination address, right? So that means the router then forwards the packet out of the interface based on that whatever it finds in the routing table. So it does the packet forwarding and it does the path selection. So the two primary function of a router, whether it's a Cisco router or any router, is the packet forwarding and path selection. Question number 19. A network administrator requires access to manage routers and switches locally and remotely. So they want to manage the routers and switches remotely, right? But also locally as well. So match the description to that access mode. So on the left hand side, we have a bunch of descriptions, and on the right hand side, we have different types of access modes that we can use with Cisco devices. So the network administrator want to know, what goes with what. So if you look at your left hand side, you see the remote access via dial-up connection, preferred out-of-band access method, remote access method via encryption, unsecure remote access. So all of these are user accesses and can be also machine accesses as well. And the answers on the right hand side says SSH, console, FTP, aux, and telnet. So we just need to match what goes with what. So if you look at the remote access via dial-up connection, well, it's a really old product method, and remember that most likely you guys know that what it is going to be aux connection. So it's a remote access via dial-up connection, always going to be aux. Preferred out of band access method, well, out of band, what does out of band means? That means the router or the switch is having trouble doing packet switching and stuff, so basically it's going to be console. Remote access method via encryption, so the only one in here that by definition contain encryption is SSH, so that's the answer to that one. And finally, unsecure remote access will be the older method of predecessor to SSH, I would call it, is the telnet. So the unsecure remote access is going to be telnet. So those are the answers. So on the Cisco exam, it would be most likely you have to drag these things and put it into which one matches, or drag this one and put it into which one matches. So you'll drag this SSH and put it underneath here, or you'll drag remote access method encryption and put it underneath it here. But at the end of the day, this is basically a matching question that you should be able to answer. Question number 20. What property of ARP allows host on a LAN to send traffic to remote networks? Recall what ARP is, so I'm not going to repeat that. So what property of ARP allows hosts on a LAN to send traffic to remote networks? The answers include the local host learn the MAC address of the default gateway. The destination MAC address contain all lefts appears in the header of the Ethernet frame. The source MAC address appears in the header of the Ethernet frame. The port to MAC address table on a switch has the same entries as the ARP table on the switch. I'll give you a couple of minutes to think about it and read the question. Couple of seconds. You know, on the real exam, you probably have about a minute or 2 minutes to think about the question after you read it, depending on typical reading speed of a Canadian, I would say. So if you're Canadian or American, you know, typical reading speed, you probably have, after reading the question and answer, you probably have a minute or two. If you spend more than that time, you're probably going to run out of time at the end of your exam. So keep that in mind, because there are some packet tracer questions too, which I don't cover in this lecture. So the answer to this question is the local host learned the MAC address of the default gateway, and that's the property that allow the host on a LAN to send traffic to a remote network. It learns the MAC address of the default gateway. Question number 21. When transporting data from real-time applications such as streaming audio and video, which field in the IPv6 header can be used to inform the routers and switches to maintain the same path for packets in the same conversation? So which transporting data from, when transporting data from a real time applications, right, where it is critical that we keep the same path for the packet, how do you do that? Next header, flow label, traffic class, differentiated services. Next header, flow label, traffic class, differentiated services. Again, I will give you a couple of seconds to think about this. So the answer to this question is flow labels. And remember, the flow label in IPv6 header is a 20-bit field that provides special service for real-time application. So in other words, this field can be used to inform routers and switches to maintain the same path so that it won't be reordered in any way when the next packet comes in and the next packet comes in. So the flow label in the header of the IPv6 is what controls the real-time application switching transmit of that packet. Again, you need to understand IPv4 header sections and the IPv6 header section in order for you to properly answer this question. The flow label, for example, right here in the IPv6 header is what basically give the ability for the IPv6 routing and switching to allow that the real-time application to be transmitted on the same connection. So maintain the same path and same flow and the path using that flow label. So flow label will identify that in the IPv6 header. Again, you need to understand, if you don't remember IPv4 headers and IPv6 header, at least memorize this diagram. This is directly from Cisco. Question number 22. Which statement describes a feature of an IP protocol? Which statement describes a feature of the IP protocol? IP encapsulation is modified based on network media. IP relies on layer 2 protocols for transmission error control. MAC addresses are used during the packet encapsulation. IP relies on upper layer services to handle situations of missing or out of order packets. So what are these? When you look at these statements, which of these statements is actually true? That's the question with respect to IP protocol. Which statement describe a feature of the IP protocol? In other words, which of these statements are actually true? So I'll give you the answer now. IP relies on upper layer services to handle situations of missing or out of order packets. Because remember, IP protocol is a connectionless protocol. I mentioned this before, and consider unreliable in terms of end-to-end delivery, right? So it does not provide error control in the cases where receiving packets are out of order, or in some cases of missing packets, etc. So what it has to do in the IP protocol, it relies on the upper layer services such as TCP to resolve this issue. Remember, TCP versus UDP, you may have covered already on your classes. TCP can provide the reliability, as opposed to UDP doesn't have the reliability, but those are all upper layers. IP protocol is much lower layer, so it is actually relies on the upper layers to handle those kind of situations, because IP protocol is a connectionless protocol. Question number 23. Why is NAT not needed in IPv6? First of all, again, you need to understand what is NAT. NAT is Network Address Translation. So the question here is, in IPv4, we use NAT. Your router between your house and the outside world act as a NAT. It is a network address. If you had two routers in your network, it's gonna have double NAT situation if it is right behind each other, which I have explained in detail in my Cisco CCNA lecture videos. So the question here is, why don't we even consider, and why don't we bother about NAT in IPv6? So the answers include, because IPv6 has integrated security and there is no need to hide the IPv6 addresses of the internal network. Any host or user can get a public IPv6 network address because the number of available IPv6 addresses is extremely large. The problems that they are induced by NAT applications are solved because IPv6 header improves the packet handling by intermediate routers. The end-to-end connectivity problems that are caused by NAT are solved because the number of routes increases with the number of nodes that are connected to the internet. So with respect to IPv6, what's the answer here? This is a very simple answer if you understand why we even need IPv6, why we have created IPv6 at the first place. Why are we moving away from IPv4? So the answer to this question is, any host or user can get a public IPv6 network address because the number of available IPv6 addresses is extremely large. The reason why we created NAT at the first place is not as a security measure. A lot of students, sometimes a lot of people who are new to network engineering and CCNA programs get confused about this concept. NAT is not a security concept. Network address translation cannot be used as a security concept. Firewalls are what we put between your internal network and our external network to provide you security. NAT is simply a method of conserving IPv4 addresses, because your internal IP addresses can be now different from the external IP addresses. Hence, IPv4 exhaustion can be eliminated or reduced using the NAT. So network address translation is not needed in IPv6 because the host can get a public IPv6 network address because the number of available IPv6 addresses is extremely large. Yes, there are IPv6 private addresses, which I will, you don't need to know much about in CCNA 1, I don't think so. But you can go and watch my lecture videos for more details on this. So NAT is not needed in IPv6 because you have a large number of available IPv6 addresses. Question number 24. A computer can access devices on the same network but cannot access the devices on other networks. This is the same question, similar questions as I covered before. What is the probable cause of the problem here? The answers include the cable is not connected properly to the NIC, network interface card. The computer has an invalid IP address. The computer has an incorrect subnet mask. The computer has an invalid default gateway address. So computer can communicate within its own network. Devices connected within the same subnet, same within their own network, but cannot communicate outside. This is an easy answer because I have already covered it. So I'm going to give you the answer right now. It is the computer has an invalid default gateway address or missing default gateway address. So you could have a host with missing default gateway address or invalid default gateway address. That will result in computer that can communicate within the same network but cannot communicate with devices outside of its network. Question number 25. What IPv4 header field identifies the upper layer protocol carried in the packet? Again, you need to memorize or understand or remember the header fields of IPv4 and IPv6 to answer this question. So the question is, in IPv4 header, what upper layer protocol, what IPv4 header field identifies that upper layer protocol carried in the packet? That includes the protocol, identification, version, or differentiated services. So that's the question. So that's the answers they give you. So again, if you understand the packets headers, the answer to this question is the protocol. I'm not going to show you that IPv4, IPv6 diagram again here because I just showed you a couple of minutes ago. So the answer to this question is the protocol. So remember, it is the protocol field in the IP header that identifies the upper layer protocol which the packet is carrying, and the version field identifies the IP version. So it can be the version, it just show the IPv4 versus IPv6 version. And the differentiated services field is used for what? Setting the packet priority, right? So that can be that either. So identification field is used to use also for the fragmented packets. So the answer has to be the protocol. You can eliminate answers like that too by thinking ahead in your head. Question number 26. Which term describes a field in IPv4 packet header that contains 4-bit binary value set to 0, 1, 0, 0? This is a unique 4-bit binary value associated with IPv4 packet header that you have to memorize if you don't understand how packet switching with IPv4 works. So I'll give you a few minutes to think about it. It could be the version, it could be differentiated services, it could be the header checksum, or it could be TTL, which stands for time to live. What is time to live? It tells what happened to a packet if that packet cannot reach the destination, so that the packet doesn't stay on the network forever. It has a time to live, TTL timer, so the packet will eventually die, so it won't clog up your network. So that's what the time to live or TTL stand for. So in this question, we are asking, with respect to IPv4 packet header, with this unique 4-bit binary value set 0, 1, 0, 0, what does that describe? The answer is version. It basically tells the version of the packet. So that's why we have that 0, 1, 0, 0. Question number 27, we are looking at another CLI, or the configuration screenshot, from a Cisco device, and we're gonna answer questions based on that. So I'll give you a little bit of time to look at it. It's on the top left hand corner, and we have a gateway of last resort set to zeros with the network 0 all, and we have a bunch of information appearing here, and this should be familiar to you if you have studied your labs associated with your CCNA 1, because this is a familiar screen, and remember what this means. I'm not going to go into detail right now, but you should know what they are. So what we need to do, we need to match whatever you see right here on the bottom on the left hand side to whatever you see on the right hand side list on this side. On a real Cisco exam, again, you may have to drag these things and put it underneath each one of these, which one match goes with what. And we will answer one question at a time, so one section at a time. So I'll give you a few minutes to think about it and answer your own. And this is one of those questions you could maybe spend like maybe 2 minutes to answer the question after reading through it, and you'll still have some time left at the end of the exam. So I taken this out directly from a Cisco exam, and here's a screenshot, and it has some information with the configuration of this particular Cisco device. So the first one says packets with destination of 172.17.10.5. What Ethernet port or what interface, this type of packet with a destination 172.168.10.5 will be spitting out. Like, where does it will go? If you look at these things, and if you look at all these IP addresses associated with that, the 172.17.10 network is associated with fast Ethernet 1.1. We know this because right here we have 172.17.10.0, and then it has the IP address 192.168.5.2, and then it is associated with fast Ethernet 1.1. So if the destination packet has 172.17.10.5, it matches all the way to this, that matches this network, so it has to be the fast Ethernet 1.1. So the answer to that, this should goes with fast Ethernet 1.1. So the next one is packet with destination 172.17.12.10. Go and look for 172.17.12.0. So that's the network we are looking at, and it is related to 1.0, right? So that means using that logic, the same logic we used previously, based on this CLI screenshot, this 17.12.10, because it's this 12.10 is associated with 172.17.12.0, it has to be 0.1. So it has to go with this guy. So that's the answer. So a packet with that destination 12.10 will be fast Ethernet 1.0. That's where it's going to be going out of. Packets with destination of 172.17.14.8 use the same logic. 172.17.14.0 is directly connected, and it has fast Ethernet 0/1. Fast Ethernet 0/1, and that has to be on this list is this guy. So this 14.8 has to go with that guy, and the answer going to be there. So in Cisco exam, you probably have to drag it underneath here and put it in there. And the next one, packets with destination 172.17.8.20. So again, we are looking for 8 dot something, and it's missing. So you're looking at this on the exam, you go like, oh no, the 8.1 is missing. What happened to it? So it's not here. It's not right here because it's 6.0, this is 10.0, this is 12.0, this is 14.0. So where is this 8.20, 172.17.8.20? It is not here. These are 192s. So where is this going to? If you look at this, the very last entry, it has directly connected to a serial 0000. This is like a catch-all, packets kind of thing. So what this is going to happen, what this is going to do is this 172.17.8.20 is not defined anywhere else in here, not configured anywhere else in here, and it will go into the serial 000 because of this one single entry, this one line on this configuration. And finally, the packet with 172.17.6.15. Well, it's 6.15. So where does the 172.17.6.0 is? 6 here is right here, and it is part of the fast Ethernet 00. It has to be this one at the top. So we need to match that packet with right here. So all the packets with this type of destination gonna go out of the with fast Ethernet 0.0. So one thing that you might get it wrong or get confused or get stuck on, the packets with destination 172.17.8.20, because it's not defined anywhere in here. In that situation, remember the *1, so that's like a catch it all, and whatever that is related to, in this case serial 000, is the answer to that question. So you didn't find the 172.17.8.0 network here, but because of this entry, we know it is associated with serial 000. So that's the answer to this question. Question number 28. Which destination address is used in an ARP request frame? So which destination address is used in an address resolution protocol request frame? 0000 is the code zeros, or code 255s, 255, 255, 255, 255, or all Fs, so code Fs, all A's, so code A's, the physical address of the destination host. So which destination address is used in an ARP request frame? Again, you need to understand the purpose of ARP. So the whole point of ARP in IPv4 is what? So ARP is used to find a MAC address of the destination host on the Ethernet LAN, right? So the ARP process ends a layer 2 broadcast to all devices on the Ethernet LAN. So what does that mean? The frame contains the IP address of the destination and the broadcast MAC address, and the broadcast MAC address of that has to be all card F. So you need to understand how ARP works to answer this question. So that's the answer to that question. Question number 29. What property of ARP, address resolution protocol, causes cache IP to MAC mapping to remain in memory longer? So instead of every single time an ARP request comes around, it's keep matching to IP to MAC, because that's one of the things, one of the functions of ARP. What property of ARP causes to be, those to be cached? So the answers include the entries in the ARP table are timestamp and are purged after the timeout expires. A static IP to MAC address entry can be entered manually into an ARP table. The type field 0x806 appear in the header of the Ethernet frame. The port to MAC address table on a switch has the same entries as the ARP table on the switch. So again, I will give you a couple of seconds to think about it. This is an easy answer if you understand how ARP works. So the answer to this question is the entries in an ARP table are timestamped and are purged after the timeout expires. So that's the answer to this question. Question number 30. Which term describes a field in IPv4 packet header that contains a 4-bit binary value set to 0100? Again, I think I may have asked this question before. Sorry about that if that's the case. Again, you need to know how IPv4 packet headers work. So the answers are source IPv4 address, time to live or TTL, protocol or version. So this is something you need to memorize if you don't understand. The answer is the version, because this is how the convention works. This is how we decided the IPv4 protocol works. Question number 31. Which 3 commands are used to set up secure access to a router through a connection to the console interface? You need to pick 3 answers here. So we're asking for 3 commands that we can use to secure access to a router through a connection to the console interface. So they include the answers listed here: the interface fast Ethernet 00, line VTY 04, line console 0, enable secret Cisco, login, password Cisco. So which 3 commands you have to use, you must use to secure access to a router through a connection to the console interface? Again, if you have done your labs, you should be able to answer this question very easy. Those includes line console 0, login, password Cisco. Line console 0, login, password Cisco. The 3 commands that you need to protect the console port are basically line console 0, password Cisco, and login, in that order, like line console 0, password Cisco, login. So you need to enter line console 0 first, password Cisco next, and login next. Not, the answers are not in order. So you need to go line console 0, password Cisco, login. But these are the 3 commands that you need. Remember that in this situation, the interface fast Ethernet 00 command, like this guy, is commonly used to access the configuration mode used to apply specific parameters such as IP addresses to that particular Ethernet port, which is fast 0, FA00, for example. Line VTY 04, if I look at that, basically it's a command used to access the configuration mode or telnet. So that basically, the line VTY, lines from 0 all the way to 4, is a parameter that goes through all those ports and configure those things simultaneously for the telnet connections. And enable secret Cisco command is used to apply password use on the router to access privilege mode. So this is part of the privilege. So the answer to this question, the secure access to router through a connection to a console interface, should be the line console 0, password Cisco, and logging in that order. And answers are all these three answers. Question number 32. Refer to the exhibit. So the exhibit on the top right hand corner right here. So you're referring to that exhibit. Consider the IP address configuration shown from PC1. What is the description of the default gateway address? What is a description of the default gateway address? Remember, this screenshot right here is taken out of PC1, and this is a diagram we have. We have PC1 connected to a switch, connected to a router, and there's internet or bunch of networks in between, and then you have a router here and a switch and a PC2 right here. So this is the configuration, and this is a screenshot coming from a PC1. And we have, what do we have here? We have the DNS information, we have the IP address of that PC, we have the subnet mask, and we have the default gateway. So it is asking what is a description of the default gateway address we can find in these answers. So the answers include, it is the IP address of the router 1 interface that connects the company to the network. In other words, it is the interface of this guy right here. It is the IP address of the router 1 interface that connects the PC1 LAN to router 1. So in other words, this is connecting to the router 1, right? It is the IP address of the switch 1 that connects the PC1 to the devices on the same LAN. So it is IP address right here. It is the IP address of the ISP network device located in the cloud. So it is the IP address coming from in here. So what's the answer to this question? So the answer is it is the IP address of the router 1 interface that connects the PC1 LAN to router 1. So it is that interface IP address. So right here, this is, so the default gateway IP address, which is the 192.168.1.254, must be the IP address of right here, this port, this Ethernet, the port associated IP address is what's showing up on this PC as a default gateway. The best explanation I can give is the default gateway is used to route the packets destined for remote networks, and the default IP address is the address of the layer 3 device, the first layer 3 device pretty much typically that is associated with a network that is connecting to a device, right? So then the device is looking for that default gateway, is looking for that default IP address or of that interface, IP address of the router interface that is immediately connected. So in that case, it should be this one. So that's the best way I can explain that. Question number 33. What property of ARP, address resolution protocol, causes a reply only to the source sending an ARP request? So what property of ARP causes a reply only to the source sending an ARP request? The answers include the source MAC address appears in the header of the Ethernet frame. The destination MAC address have all Fs appears in the header of the Ethernet frame. The type field 0x806 appears in the header of the Ethernet frame. The ARP replies are broadcast on the network when a host receives an ARP request. The answers may be familiar to you now because these are same answers appearing on multiple questions, but the question is different. In this time we are asking what property of ARP causes a reply only to the source sending an ARP request. So if you understand how ARP works, this is an easy answer. So I'll give you the answer right now. So it is the source MAC address appears in the header of the Ethernet frame that causes reply only to the source sending an ARP request. So that's the answer. The source MAC address appear in the header to the Ethernet frame, header of the Ethernet frame. Question number 34. A router receives a packet from gigabit 00 interface and determines that the packet needs to be forwarded out the gigabit 01 interface. So router receives the packet on gigabit 00, but it determines that it needs to exit at gigabit 01 interface. what will the router do next? So router receives a packet on one port and it determines that it needs to be forwarded in another port. So what would the router does, right? So the answers include route the packet out gigabit 01 interface, create a new layer 2 Ethernet frame to be sent to the destination, look into the ARP cache to determine the destination IP address, look into the routing table to determine if the destination network is in the routing table. So there's a couple of answers possible. Which one is correct? If you understand how routing works from your lecture notes, the answer to this question is the router going to create a new layer 2 Ethernet frame to be sent to the destination, because now router determine that it needs to go out from a different port. So that's the answer to question number 34. Question number 35. Again, we have an exhibit of a screenshot of a configuration, a Cisco configuration on the bottom right hand side. And based on this screenshot, the question is, a network administrator is connecting a new host to the payroll LAN. The host needs to communicate with the remote networks. What IP address would be configured as the default gateway of the new host? Again, Cisco may give you a packet tracer file to answer this question. In that case, you need to figure out that by going into the configuration of the host and figure out what is the gateway and check the gateway of it is connecting to. In this situation, we don't have that luxury. We have a screenshot of the configuration on the bottom right hand corner. First thing I'm going to do in these questions, again, I'm going to look at what they're asking. They're asking payroll LAN. The only way I know which one is a payroll LAN without a packet tracer file, because they gave you a description what is what. In here it says description connects to the payroll LAN. In here description connects to the marketing LAN, ISP, head office, blah blah blah. So now we know this is the payroll LAN. Look at the IP addresses under that payroll LAN interface, this interface GI00. So the payroll LAN has the IP address 10.27.14.148 with the 255.255.255.0 subnet mask, right? So in other words, the payroll LAN has the default gateway configured as 10.27.14.148, and that should be the answer here, because the device is connecting to the payroll LAN and it says right there, and there's no way to verify anything else here without a packet tracer file or some kind of a lab file. So based on this screenshot and knowing that this is considered as described as a payroll LAN, and this is the network address for payroll LAN 10.27.14.148, so the answer must be 10.27.14.148. So that's the answer to this question. Again, without this description up here, without giving this description, we wouldn't know this. There's no way to verify this. You just have to look at the configuration and the description here and then figure out the answer. Question number 36. What is one advantage that IPv6 simplified header offers over IPv4? So remember the IPv4, IPv6 headers? Again, recall that image that I told you that you need to memorize. So based on that, between the IPv4 and IPv6, what is one advantage of IPv6 simplified header? Smaller size header, little requirement for processing checksums, smaller size source and destination IP addresses, efficient packet handling. Right away, I know it is not smaller size source and destination IP addresses, because IPv6 actually IP address is bigger than IPv4, right? In certain ways. So the answer to this question is efficient packet handling. The one of the biggest advantage that IPv6 simplified header offer is it is efficient packet handling. IPv6 simplified header offers several advantages, not just that, but it is one of the advantages. So IPv6 offer better routing efficiency and efficient packet handling and performance forwarding rate scalabilities. It also offers no requirement for processing checksums as well. It also simplifies and more efficient than the extension header mechanisms that we use in the IPv6. sorry, IPv4, and the flow label field per flow processing with no need to open, transport in a packet and etc. A whole bunch of stuff that you should know with IPv6. For this question, you need to know that it's efficient packet handling. Question number 37. What is the aim of an ARP spoofing attack? So like, what's the point of ARP spoofing attack? So you probably have studied this in your lectures. ARP stands for, again, Address Resolution Protocol, and there's a way to that hackers can get in through what we call the ARP spoofing attack. So what is the aim of that? The answers include to flood the network with ARP reply broadcast, to fill switch MAC address tables with bogus addresses, to associate IP addresses to the wrong MAC addresses, to overwhelm network host with the ARP request. So what is the main aim? Like, what is the purpose of an ARP spoofing attack? Again, you should know what this is by just studying your notes, lecture notes. I will give you a diagram of how this works as well, like an overall diagram from, I got it from Wikipedia. Next, so the main aim of the ARP spoofing attack is to associate IP addresses to the wrong MAC address. So the IP address is a valid IP address in the network, but the ARP spoofing will spoof the MAC address, spoof what the real address should be, and then the attacker can gain access to your network, because they can now use that spoof MAC address to capture packet and spy on your network and do stuff, etc., etc. So if I look at this diagram that I took it from the Wikipedia, typically how routing under normal circumstances, normal operation happen is that you have a LAN user, and through a hub or a switch, it just go through to the next LAN user and go to the internet. Through the gateway, LAN gateway, and go to the internet. Remember, the gateway is allowing us to communicate between different networks, so the LAN user can access the internet. In a ARP spoofing attack, also known as ARP cache poisoning attack, there's another term that you may see on your Cisco CCNA lecture notes and other lecture notes. What happened is at the hub switch, the malicious user, the malicious attacker, going to spoof that IP address with their own MAC address or a infected MAC address, and then it basically, every single time a LAN user send a request, it go through the malicious MAC address and then go out the window, and then coming back, it goes through that malicious user's device and then reach the end device, the host. So that's what the ARP spoofing does. It is also known as ARP cache poisoning sometimes. Question number 38. A new network administrator has been asked to enter banner message on a Cisco device. What is the fastest way a network administrator could test whether the banner is properly configured? A new network administrator just need to know how to get into a Cisco device and figure out what the banner message in that device. So this is again a lab question. If you have done labs, you would know this. So the answers include reboot the device and it'll pop up the banner message. Enter CTRL Z at the privilege mode prompt. Exit global configuration mode. Power cycle the device. Exit privilege executive mode and press enter. So I will give you this a little bit time for you to think about your labs. Okay, now one thing I want to tell you is the rebooting the device or power cycling the device will show the banner. But if you are a new network administrator, you reboot a device in production, you reboot or power cycle a device in production environment, or you're probably going to get fired on the spot, because a lot of users are going to lose their network connections, etc., etc. Unless, if your company is understanding, mistakes happens, but still you don't want to make that mistake. So what's the easy way to check that banner message which are doing reboots or a power cycle which will disconnect everything? Well, exit privilege mode, and then press enter. Like if you exit out of the privilege mode, if you are in the privilege mode, if you exit out, or you log into privilege mode and exit out, and press enter, and it will display the banner message. And the thing about this is you need to understand how Cisco, Cisco different levels of Cisco privileges in your Cisco switches and routers. So recall that the iOS, the Cisco firmware in your router or modem, it has different levels, different modes. They includes like the executive mode. It includes user executive mode. Then we have the privilege executive mode, and then we have global configuration commands that can be entered. Then we have the interface command that can be entered, and then you can have other items associated with that. So remember, you need to know from your lab material to answer this question, that what is user executive mode and what does the user executive mode in a Cisco iOS software does, versus as opposed to privilege executive commands and global configuration commands. Like, what are the user executive commands, privilege executive command, global configuration? These are like containers within Cisco iOS firmware that containerize or isolate different modes, allowing you to navigate across the different areas of your device. So to answer this question, you need to exit the privilege executive mode and press enter. So if you are in the privilege executive mode in this section, when you exit out at the user executive command mode, you will see that message. So you need to know this like back of your hand. By doing many labs, like you will get to know this better than just doing lectures. Question number 39. Refer to the exhibit, which is on the bottom right hand corner. A user PC has successfully transmitted packets to www.cisco.com. Which IP address does the user PC target in order to forward its data off the local network? So it's asking what IP address the PC has targeted in order to send data off local network. So again, we are talking about routing protocols right now, routing. So you're looking at this. You can do the trace RT to any website on your own device too, like www.sanuja.com, for example. And this lab environment example, they have done this, cisco.com, and these are the data that came out. So you're asking which IP address does the user PC target in order to forward its data off the local network. We are doing the trace from the PC. We know this because right here it says PC, right? So the answer to this question is 172.20.0.254. And we know that because the first hop right here is 172.20.0.254, and that is basically proving that is what we're gonna use the target from the PC itself, because that's the only one that PC originally knows. And we know that from this table because that's the first hop. 172.20.0.254 is the first hop, and that's the first hop address, and that is what the target address in here. Question number 40. We are looking for two answers, and the question is, what are two potential network problems that can result from ARP operation? So ARP is great, address resolution protocol, when we use it IPv4, but there are some potential problems that ARP could cause. So what are some potential problems? So the answers include manually configuring static ARP associations could facilitate ARP poisoning or MAC address spoofing. On large networks with low bandwidth, multiple ARP broadcasts could cause data communication delays. Network attackers could manipulate MAC address and IP address mapping in ARP messages with the intent of intercepting network traffic. Large number of ARP requests broadcast could cause the host MAC address table to overflow and prevent the host from communicating on the network. Multiple ARP replies result in switch MAC address table containing entries that match MAC address of hosts that are connected to the relevant switch port. So these are like the answers, possible answers of two potential network problems. I'll give you a few minutes to think about it because there's a lot of text in here, like few seconds. Should be an easy question too. So the answer is, on large networks with low bandwidth, multiple ARP broadcasts could cause data communication delays, and the network attackers could manipulate the MAC address and IP address mapping in ARP messages with intent of intercepting network traffic. Those are the two potential network problems with ARP, which I already explained, like ARP, can, like a spoofing type of attack right here. So those are the two answers. So remember, large number of ARP broadcast messages could cause momentary data communication delays, especially if the bandwidth is very small, and the network attackers could also manipulate the MAC address, IP address, MAC address and IP address mapping in ARP messages with the intent to intercept that information, and then could do ARP poisoning attacks, right? ARP requests and replies cause entries to be made into the ARP table. Remember, not the MAC address table. So there's a ARP table is separate from the MAC address table, and the ARP table overflows are very unlikely, but it could happen. If you look at the overflow answer, the large number of overflow, it could happen, but it's very unlikely going to happen that. And manually configuring static ARP, the other answer here, manually basically configuring ARP's association actually prevent ARP poisoning attacks, because now everything is like manually configured. It may not be ideal, but actually can be used as a security measure, manually configuring that. This is how I think it in my brain. Like, this is one of the explanation I can give you, to this question. Question number 41. Which term describes a field in the IPv4 packet header used to identify the next level protocol? Again, I think I may have asked similar question before. So the answers include protocol, version, differentiated services, and header checksum. Again, should be an easy answer. It is protocol. A network protocol is an established set of rules, remember, that determines how data is transmitted between devices on the same network. So which term describes the field in IPv4 packet header to use to figure out which next level protocol? It is basically protocol. Question number 42. Which term describes a field in IPv4 packet header that contains a unicast, multicast, or broadcast address? Which term describes a field in the IPv4 packet header that contains a unicast, multicast, or broadcast address? Destination IPv4 address, protocol, TTL, also known as time to live, or header checksum? Very easy question. So it's asking for a packet header that contains a unicast, broadcast, or multicast address. So it has to be the destination IPv4 address. Again, I'm gonna drill this into your head. You need to remember your IPv4 and IPv6 headers, and the breakdown of these headers and what these do in order for you to do well in your CCNA exam. Okay, keep that in mind. I score like 97 to 100% on every single CCNA exam, probably 95 to 100% on every single CCNA exam, because I understand the concept behind the IPv4 header and IPv6 header, and also the differences between those two and how those breakdowns matter. Question number 43, another matching question. Match the command with the device mode at which the command is entered. So on the left hand side we have the command, on the right hand side we have the mode in which we are in Cisco routers and modems. Routers and switches, where we can enter these things. This is basically a router example. So all of these are routers, and we want to know where, which one goes with what. Logging will go with the config line. How do I know this? By labs. If you don't remember labs, go and check the labs. So I'm just going to give you the answers here because you should know this by like back of your hand. Service password encryption goes with the config. IP address, and then the IP address will go with config if. Copy running config and startup config, which is saving your configurations, which is going in here. This is a hash pound thing. And then the enable will go with the main just going into the more router. So as soon as you boot up the router, enable is like you go in, right? So that's what it is. So these are the answers. Again, I'm not going to explain this in detail because you should know this. Remember the Cisco iOS firmware. Cisco iOS firmware has a hierarchical structure, and you need to know what user executive, privilege executive, and global configuration commands in order for you to answer this question. So in order to get this question right, you need to understand this from your labs. So that's the answer to that question. Question number 44. What are two functions of NVRAM? To store the routing table, to retain contents when power is removed, to store the startup configuration file, to contain the running configuration file, to store the ARP table. You need to pick two because there are two answers are correct here. So I'm gonna give you a couple of seconds to think about this. Remember, NVRAM is a permanent memory storage, right? NVRAM in Cisco devices is a permanent memory storage. So it is used for what? Well, it's used to retain content when the power is removed, and it will store the startup configuration file. So once you configure your Cisco device, it will remember the configuration options. So that's what those two. Question number 45. Again, we are referring to an exhibit, which is a screenshot of a Cisco device CLI. It's on the bottom right-hand corner right here. A network administrator is connecting a new host to a medical LAN. New host to the medical LAN. The host needs to communicate with remote networks. What IP address would be configured as the default gateway on the new host? Again, this is the same question but different screenshot. Remember, I told you, unless Cisco give you a packet tracer file, you don't know what is medical LAN and what is connected to medical LAN and what IP addresses on the medical LAN. Because they gave you, instead of a screenshot, the only way you know through the description. If this description is wrong, you are not responsible for that. So right here, the first description here is the medical LAN is up here. And its network address is set up as 192.168.201.200 with the 255.255.255.0 subnet mask. That means this is the host, host gonna use for remote communication. This will be any host that connected to medical LAN segment or LAN section, and going to have 192.168.201.200. That is this IP address, that is default gateway, and that's the answer to this question. This is very similar to the previous questions that I did. Question number 46. What property of ARP, address resolution protocol, allows MAC addresses of frequently used servers to be fixed in the ARP table? So what property of ARP allows the MAC address of frequently used servers to be fixed in that table, right? The answers include a static IP to MAC address entry that can be entered manually into an ARP table. The destination MAC address, all Fs, appears in the header of the Ethernet frame. The source MAC address appears in the header of the Ethernet frame. The port to MAC address table on a switch has the same entries as the ARP table on the switch. So those are the answers, possible answers. Again, if you know how ARP works, at this point, you should know the answer. So the answer to this question is a static IP to MAC address entry can be entered manually into an ARP table. And that's a property of ARP that allow MAC addresses of frequently used servers to be fixed in the ARP table. You can manually enter that. It also can be used as a security measure that will prevent ARP spoofing attacks, as I mentioned previously. Question number 47. What statement describes the function of the address resolution protocol? In other words, what statement describes ARP? What's the function of an ARP? ARP is used to discover the IP address of any host on a different network. ARP is used to discover the IP address of any host on the local network. ARP is used to discover the MAC address of any host on a different network. ARP is used to discover the MAC address of any host on the local network. Again, if you understand how ARP works, this is an easy answer. So answer to this question is ARP is used to discover the MAC address of any host on the local network. If you don't remember what ARP is, go and check my YouTube videos on CCNA 1 lectures. Question number 48. Under which two circumstances will a switch flood a frame out of every port except the port which the frame was received on? In other words, except the ingress port, which is the incoming port, egress port is going to be everything else. So under what kind of two situations where a switch will flood the frame out of every single port except the ingress or receive port? The answers include the frame has the broadcast address as the destination address. The destination address is unknown to the switch. The source address in the frame header is the broadcast address. The source address in the frame is a multicast address. The destination address in the frame is a known unicast address. Think about how the switch operates with frames. This is an easy question. So the only time it will flood every single port is if the frame has the broadcast address as the destination address. That's one situation, and the other situation is the destination address is unknown, so the switch doesn't know where it needs to go, so it'll just throw it out. If the frame is a broadcast address, it has to flood everything, otherwise it won't be working as a broadcast. The whole point of broadcast is broadcasting to everybody. When the destination address, however, not known, we know the destination address is there, it is not a broadcast address, but because the switch doesn't know where the destination address is except the incoming port, it will exit out of all other ports as a result. So that's the answer to that question. Question number 49. What are two services provided by the OSI network layer? Remember the OSI layered model that I went over in my previous lectures, previous questions, as well as my lecture series on CCNA 1 on my YouTube channel. So if you recall your OSI network layer, what are the two services it provides? So the answers include, possible answers include performing error detection, routing packets toward the destination, encapsulating PDUs from the transport layer, placement of frames on the media, collision detection. Again, you won't be able to answer this question if you don't remember your OSI model. So the answer to these questions include the routing packets towards the destination and the encapsulating PDUs from the transport layer. Remember, the OSI network layer provides several services to allow communication between devices. Those include addressing, encapsulation, routing, de-encapsulation. However, the error detection, placing frames on the media, and the collision detections are all functions of data link layer. So the two services that provide the OSI model, going to be those two answers. Question number 50. A network technician issued the ARP-D star command on a PC after the router that is connected to the LAN is reconfigured. So you have a PC and the network technician reconfigure the router, and he goes to a host that is connected to that router, and on that host in this PC he entered the command ARP-D star. What is the result after this command is issued? In other words, what does this command does? So the answers could be the ARP cache is cleared, the current content of the ARP cache is displayed, the detailed information of the ARP cache is displayed, the up cache is synchronized with the router interface. So again, if you did your labs, you should know the answer to this question. It is the up cache is cleared by issuing the up-d command on a PC, and that will allow the network technicians to ensure that the cache is populated with the updated information that he has updated on the newly configured router. So the PC will receive the new up information. So it will clear the up cache on the PC by issuing this command. Question number 51. Refer to the exhibit which is on the top right hand corner right here. This is the exhibit we are referring to. The exhibit shows a small switch network and the contents of the MAC address table of the switch. So this is the MAC address table of this switch. And it shows port 1 and port 3. So the port 1 is this one and the port 3 is that one, and it shows that MAC address table. PC1 has to send a frame address to PC3. What will the switch do with the frame? So this is the MAC address table. It has the port 1 and port 3 and the MAC addresses associated with it. And the PC1, which is this guy, which is the port connected to the port 4, needs to send a message to the PC3, which is on port 2. The port 4 and 2 are not even on the MAC address table, right? That's the first thing you need to notice. So the answers could be the switch will discard the frame, the switch will forward the frame only to port 2, the switch will forward the frame to all ports except the port number 4, the switch will forward the frame to all ports, the switch will forward the frame only to port 1 and port 3. So I will let you think about this. So we have a MAC address table at the time in which the PC1 is trying to communicate with PC3, and you notice that the MAC address table only have port 1 and 3. It doesn't have the port 4 and 2, which need to be used by the PC1 in order to communicate to PC3. So what will happen in this situation? Again, remember from my previous explanation, I already gave you for my previous question a few minutes ago. The switch will forward the frame to all ports except the port number 4, because port number 4 is the ingress or incoming port. So because of the incoming port is not needed to forward the packets, it's just gonna flood or send the packets, not flood, but send the packet across all the ports except that port number 4, because the PC1 is trying to communicate to PC3, and we don't have the MAC address association between port 4 and port 4 and port 2 on the MAC address table of this switch. So as a result, it'll take that frame and forward it to all of the other port. In other words, like the MAC address of PC3 is not present in the MAC address table here, right here, and because of that, switch doesn't know where to send the frame. It will send it out on all ports except the incoming port. So that's the answer. Question number 52. What is the effect of using router, that pound symbol, or thimble or whatever they call it, symbol, copy running config startup config command on a router? So you have a Cisco router and this is the command that we are entering, copy running dash config space startup dash config command. So this is what we are trying to enter. We are entering. So what does it do? So again, this is a lab question that you should know the answer right away. Answers could be the content of the ROM will be changed, the content of the RAM will be changed, the content of the NVRAM will be changed, and the content of the flash will be changed. So which one is the right answer? Recall from your lab that the copy running dash config space startup dash config copy what to what? Well, this command, if you recall from your lab, it copies whatever on your RAM, which is temporary memory, which you use to configure your thing, and save it to NVRAM, so that when the router power cycles or lose power and come back up, it will not lose your configuration. So the answer to this question is the content of the NVRAM will be changed as a result of issuing this command, which is going to get overwritten into whatever the content in the NVRAM. And when the router powers off and power back up, it will still retain the changes that you made. So that's the answer. This is a lab question actually, related to labs. It's still a lecture question, but related to lab. Question number 53. Which field in the IPv4 header is used to prevent a packet from traversing a network endlessly? So remember, IP protocol in general, like how IP works, it's a connectionless system. It basically sends packets out. So how do we make sure that a packet won't remain in the network, and the next packet going to remain in the network because it couldn't find the destination? At the end of the day, we're going to end up with a whole bunch of packets in the network and clogging up the network. So how do we prevent clogging of the network by packets that are not delivered? So the answers could be time to live, also known as TTL, sequence number, acknowledgement number, differentiated services. Time to live, sequence number, acknowledgement number, differentiated services. You need to understand your IPv4 header. You also need to understand how packet switching works to answer this question. This is a very easy answer, but you also need to understand concepts behind it. So the answer to this question is time to live, also known as commonly TTL. The time to live is a timer on the packet IPv4 packet header that will tell that packet, that will tell intermediate devices in your network how long this packet can traverse in the network or remain in the network before the packet is discarded. The value of the TTL field in the IPv4, in other words header, is used to limit the lifetime or lifespan of that packet. The sending host is the one that's going to set the initial TTL value, which is decreased by 1 each time the packet is processed by a router. So each time the packet goes through a router, the initial value get decreased. If the TTL field decrement to 0, so in other words that at the beginning the sending will set a TTL, and each time that goes through a router it get decremented by 1, and each time it happens it lowers 1. So if the TTL decrement all the way to 0, the router, the next router that receives that packet will send it to the internet control message protocol, ICMP. In this case ICMP v4, because there's ICMP v6 as well. And then the time exceeded message to the source IP address will be sent back. The differentiated services, DS, is a field that is used to determine the priority of each packet and has nothing to do with, the differentiated service has nothing to do with how long a packet would last in a network. While the sequence number and acknowledgement numbers are two fields that are used in the TCP headers, the sequence numbers and the acknowledgement numbers, that make basically internet protocol kind of a connection type protocol as of a connectionless type of protocol. So this has nothing to do with how long the packet will remain. So the answer to this question is time to live, and I give you more than enough background information to answer maybe next questions as well. So move on to the next one. Question number 54. How do hosts ensure that their packets are directed to the correct network destination? How do hosts ensure that their packets are directed to the correct network destination? They always direct their packets to the default gateway, which will be responsible for the packet delivery. They search in their own local routing table for a route to the network destination address and pass this information to the default gateway. They have to keep their own local routing table that contains a route to the loopback interface, a local network route, and a remote default route. They send a query packet to the default gateway asking for the best route. So which answer is the best answer here? So how do the hosts ensure that the packets are directed to the correct network destination? So the answer to this question, they have to keep their own local routing table that contain a route to the loopback interface, a local network route, and remote default route. So that's the answer to this question. Question number 55. What property of ARP, address resolution protocol, causes the request to be flooded out all ports of a switch except the port receiving the ARP request? So what property of ARP that causes that to get flooded out on all ports except the incoming or ingress, ingress interface. Egress is the exit interface. So the answers are: destination MAC address have all lefts appears in the header of the Ethernet frame. The type field includes 0x806 appears in the header of the Ethernet frame. Entries in an ARP table are timestamp and are purged after the timeout expires. ARP replies are broadcast to the network when a host receives an ARP request. Again, if you understand how ARP works, it's an easy answer. The answer is the destination MAC address have all lefts appears in the header of the Ethernet frame. As a result, it will flood out all ports except the one that is there, right? One that is incoming, yeah. Question number 56. Refer to the exhibit, which is the exhibit on the bottom right hand corner right here, which is a screenshot of, again, a configuration of a Cisco device. A network administrator is connecting a new host to a service LAN. So we are connecting to something called service LAN. The host needs to communicate with the remote network. So what IP address would be configured as the default gateway on the new host? This is the exact same question that I have given to you on the previous questions, except the screenshot is different. So now we are connecting to something called service LAN. So if you look at this screenshot on the bottom right hand corner, service LAN is right here. And the IP address of the gigabit 01 or GI01 on the service LAN is 192.168.167.166 with the subnet mask 255.255.255.0. So that means the service LAN, this gigabit port, has the IP address this, and this IP address has to be used by the any device that is connecting to service LAN. So in here the answer should be this 192.168.167.166. So the answer is B, or the second answer. And again, unless you are given a packet tracer file where you can test and check these connections, you would not know that these are correct unless this description is correct. So you assume these descriptions are correct. So service LAN is associated with this, engineer LAN is associated with this, connection to ISP associated with this, head office WAN is associated with this. As a result, I know that service LAN has to be this one, and that's why I answer this is 192.168.167.166, because that's all the information I have, unless there's a packet tracer file or something where I can check this particular configuration. So that's the answer to this question. Question number 57. Which term describe a field in IPv4 packet header that contains a 32-bit binary value associated with an interface on the sending device? So we are looking at, or we are thinking about IPv4 packet header, and we are looking for 32-bit binary value that is associated with an interface on a sending device. So answers could be source IPv4 address, destination IPv4 address, the protocol, or TTL, also known as time to live. So the answer to this question is the source IPv4 address. This is an easy question again, because without knowing the source IPv4 address, we wouldn't know the the IP address of the sending interface. So that's the answer for that. Question number 58. Again, we are referring to an exhibit, which is a screenshot of a Cisco device configuration. On the bottom right hand corner, a network administrator is connecting a new host to a LAN called store LAN. The host needs to communicate with the remote network, outside network. So what is the IP address that need to be configured as the default gateway of that host that is connecting to the store LAN? So default gateway of the device that is connected to the store LAN has to be the IP address of that port, right? Of that network port. In this situation, again, I'm looking at the screenshot. There's no packet tracer file, no way to verify anything else other than looking at the description. The store LAN is this guy, because this is branch LAN, the store LAN. So store LAN is in network interface GI00, and the IP address of the store LAN interface is 172.20.132.13 with subnet of 255.255.255.0. So that means any device that connected to the store LAN has to have 172.20.132.13 address. So it has to be this address. So that's the answer, 172.20.132.13. Again, you don't know anything other than what was provided to you by Cisco. And in here, it's basically a screenshot that says this is the store LAN and this is the interface IP address. And therefore, any device that is connecting to this network store LAN has to have a default gateway IP address of 172.20.132.13 in order to communicate to the outside world. So that's the answer. Question number 59. Within a production network, what is the purpose of configuring a switch with a default gateway address? So why do we need to give a default gateway address to a switch? Hosts that are connected to the switch can use the switch default gateway address to forward packets to a remote destination. A switch must have a default gateway to be accessible by telnet and SSH, in other words, remote access. The default gateway address is used to forward packets originating from the switch to remote networks. It provides the next hop address for all traffic that follows through the switch. I'll give you a couple of seconds to think about this because there are a couple of answers that are maybe you're thinking is possible, but there's a correct, real, definite answer here. So I'm going to give you that answer now. If you haven't got it yet and if you're confused about the answers here, maybe pause the video. The answer to the question here is the default gateway address is used to forward packets originating from the switch to remote networks. You may have thought about this one. The hosts that are connected to the switch can use the switch default gateway address to forward packet to a remote destination, but that's not the correct answer. This is the correct answer. Basically, a default gateway address allow the switch to forward packet that are originate from that switch to a remote network because it allows it to communicate the outside world, right? A default gateway address on the switch does not provide layer 3 routing. Layer 3 routing is like a router, right? So for PC that are connected on that, it doesn't provide layer 3 routing, but it still allow it to, use the default gateway address to forward packets from originated to a remote network. So that's why this answer is incorrect. The top answer is incorrect because switches don't do layer 3 unless it is a layer 3 switch. But then that case it has to specifically say layer 3 switch. So we had to pick this answer. So that's the answer. Question number 60. Refer to the exhibit, which is on the bottom right hand corner. PC1, which is this guy, is attempt to connect to file underscore server 1, which is this guy, and sends an ARP request to obtain a destination MAC address. Which MAC address will PC1 receive as a result of that? What does the ARP reply going to come back with for the PC1's request? So the answers could be the MAC address of the S1, which is this guy, the MAC address of the G00 interface of R1, which is this guy, the MAC address of the G00 interface of the R2, which is this guy, which is facing the file server, the MAC address of the S2, that is that guy, the MAC address of the file underscore server 1. So remember, the PC1 on this side is trying to reach the file server here, and it just have sent an ARP request looking for that MAC address. So what will happen here? This is again, if you understand how ARP works, this should be an easy answer. Give you a few seconds to think about it. So the answer to this question is the MAC address of the G00 interface on R1, which is this guy that, it will get returned back because that is the one that PC is facing. This is the interface that the router interface that the PC is facing. So that's what it will get back from this request. Question number 61. Refer to the exhibit again, and this time on the bottom right hand corner again we have a screenshot of a Cisco configuration, CLI, and a network administrator is connecting a new host to the store LAN, again called store LAN. It's right here. The host needs to communicate with the remote network. What IP address would be configured as the default gateway of the new host? Because new host is connecting to the store LAN and this is all we have, the screenshot is the only thing we got, and we don't have a packet tracer file, nothing. And because the store LAN is associated with 172.19.98.230 with the 255.255.255.0 subnet in this interface GI01, this has to be it. So it is the first answer, which is 172.19.98.230. Again, like a broken record, unless Cisco give you a packet tracer file, the only way you know this is the store LAN and this is IP address because of the screenshot description says this is the store LAN, and that's where we are connecting the device. So that's the answer to that question. Question number 62. Match the commands to the correct answer. Correct actions. Not all options are used. On the left hand side, we have a bunch of items and we have to match it with the right hand side. So left hand side we have provide security on the console, display messages on when the router is accessed, configure a name on the router. And the right hand side we have familiar things that we have seen in our labs. Again, if you did your labs and you understand the lab, this is an easy back of your hand question. And I'm just going to simply give you the answers now. So password Manuja in the line config will provides security on the console. The banner MOTD will put a banner whenever someone try to access the router. The configure config R1 config here, the host name will give you the host name of this router. So it will change from R1 to CL1 with this one. So again, if you did your labs, this should be an easy answer. Again, in Cisco exam, you may have to move these things underneath which one goes in, or move this one underneath here, not like arrows like this, but this is typically how the exam questions are structured. Question number 63. Where are IPv4 address to layer 2 Ethernet address mappings maintained on a host computer? Neighbor table, ARP table, routing table, MAC address table. So where do we keep the IPv4 address to layer 2 Ethernet addresses on a host computer? Again, this is a fundamental concept you should know, and I will give you an answer right now. It is the ARP cache table. ARP cache table will keep the layer 2 Ethernet address mapping on the host computer. Remember, what is layer 2? Layer 2 is MAC address, ARP, those are layer 2, right? Layer 3 is the IP switching, keep IP routing, right? Keep that in mind. Question number 64. What property of ARP, address resolution protocol, allows MAC address of frequently used servers to be fixed in the ARP table? Again, we have familiar, easy question. So the answers could be a static IP to MAC address entry can be entered manually into an ARP table. Entries in an ARP table are timestamps and are purged after timeout expires. The type field 0x806 appears in the header of the Ethernet frame. The port to MAC address table on a switch has the same entries as the ARP table on the switch. Again, easy question. I'm going to give you an answer right now. It is the static IP to MAC address entry that can be entered manually into an ARP table. That's the answer to that. Question number 65. Again, a screenshot of a Cisco configuration. So we are referring to the exhibit on the bottom right hand corner, which is a Cisco CLI. A network administrator is connecting a host to the medical LAN. So this time the LAN is called medical LAN. Why? Because that's how they name it. We don't know why it is. It is what it is. The host need to communicate with the remote network. What IP address would be configured as the default gateway on the new host? Now, because we don't have a packet tracer file, you might get a packet tracer file during your exam, then you need to figure out this by other means. We only have to go by the description, and the medical LAN is on G01, and that's medical LAN and has an IP address of 192.168.191.189 and with the subnet mask of 255.255.255.0, and that is this answer. So that has to be the default gateway. because that's the LAN that this device is connecting. So that's the answer. Again, you wouldn't know whether this is right or wrong except just looking at whatever provided to you. So this is says medical LAN in the description, and we are connecting the medical LAN, and it has an IP address assigned as 192.168.191.189, and so that has to be the IP address associated with the device that is connecting here for their default gateway. Question number 66, again the similar question. Refer to the exhibit on the bottom right hand corner right here, and this time the network administrator is connecting to the registrar LAN. So if you look at the registrar LAN, that's the very top one here. And what would be the default gateway again? That's right, the registrar LAN has IP address of 192.168.2.5.223 with the 255.255.255.0, and therefore the IP address of the default gateway should, on that network, all the hosts should have 225.223 because that's what we have here. Question number 67. Which statement describes the treatment of ARP, address resolution protocol, requests on the local link? So which statement describes the treatment of ARP requests on the local link? They must be forwarded by all routers on the local network. They are received and processed by every device on the local network. They are dropped by all switches on the local network. They are received and processed only by the target device. Again, think about it for a few seconds, how the ARP works. So I'm going to give you the answer now. So one of the negative issues with the ARP request is that they are sent as a broadcast, right? So this means that all devices on the local link must receive and process that request. So the answer here is they are received and processed by every device on the local network, because ARP is actually a broadcast message. So that's why, one of the issues with ARP with the limited bandwidth on large networks, the ARP could cause problems sometimes because of this. Question number 68. What property of ARP causes the NICs receiving the ARP request to pass the data portion of the Ethernet frame to ARP process? So again, I have asked, I think I have asked this question before. I don't know, I may have repeated this question. Here's the answers again. I'm not going to repeat this, the same answers that I have gone through previously. And if you look at the answers, the answer to this question is D. Type fields 0x806 appears in the header of the Ethernet frame. We have a matching question next, question number 69. Match the command with the device mode at which the command needed to be entered in a Cisco iOS firmware, right? So on the left hand side we have a bunch of commands, and we need to the modes, and on the right hand side we need to match that mode with where these commands on the right hand side will appear. Again, if you have done your Cisco labs, this is an easy answer. So the first one will go with the login. The second one will go with the copy running config startup config. Third one, this type of thing will be going in the enable. And lastly, we have this type, and that goes with the interface fast Ethernet 00. When you need to configure a Ethernet port, this is the command we use. Question number 70. Which term describes a field in the IPv4 packet header used to identify the next level protocol? I think I asked this question before, so I'm going to go quick. Here it is the protocol. That's the answer for that one. And destination IPv4 address, nope. Source, nope. It's not time to live. So protocol is the one that will figure out the next level. Question number 71. Again, we are referring to exhibit, and we are going to registrar LAN. I hope I'm not repeating these questions. That's the registrar LAN, and we need to communicate in this device that is connected to that registrar LAN, and what will be the IP address of the default gateway for that to connect to get the outside connection. It has to be 192.168.235.234.1. So that should be the last answer. That's one. Because that is how it is configured here, and again without a packet tracer file. The only reason we know this because it's clearly labeled here as registrar LAN. Question number 72. Again, we are referring to exhibit, which is a screenshot without a packet tracer file. And this time we are connecting the device to manager LAN, which is this guy, the manager LAN. And we want to know what, default IP address of that device going to be, the host needed to connect to the outside world. That's going to be 10.118.62.196. That will be this guy. And the reason why this is is because they clearly label this is the manager LAN, and the IP address associated with this interface of manager LAN is 10.118.6.196 at 255.255.255.0 subnet. Question number 73. Which term describe a field in IPv4 packet header used to limit the lifetime of a packet? I already introduced this to you previously. It is TTL, which is the time to live. So that will determine, by the packet switching that, when the packet will get discarded, when the packet cannot be delivered to its destination. And then remember, the original sender will set the TTL timer, and every single time it passes through a router, it decrement by 1 until it's reached to 0 and it get discarded. So it's called time to live or TTL. Question number 74. Match the phrases on the functions during the boot up process of a Cisco router. You need to know what is the boot up process of a Cisco router, otherwise you won't be able to answer this question. So on the left hand side we have phase 1, phase 2, phase 3, and on the right hand side we have a bunch of stuff that happened during the boot sequence or boot up process or bootstrap boot up sequence. We call it the typical Cisco bootstrap sequence. So this is referring to typical Cisco bootstrap sequence. What happened in that booting process? So again, you need to know this like back of your hand. Phase 1, it performed the post power on self test and load the bootstrap program. In phase 2, it locates and reload the Cisco iOS software. And in the phase 3, what happened is it locates and loads the startup configuration file. Again, this should be in your notes. That will describe that process, and you need to memorize this if you don't understand how it works logically. So in typical Cisco bootstrap sequence, it goes from post bootstrap Cisco iOS configuration in that order, and in post it just perform the post, the power on self test from the ROM, and in the bootstrap it loads the bootstrap program. It is also taking out from the ROM, and when the Cisco iOS start kicking in, it will locate the iOS from the flash or the TFTP and then start loading that, and it will load the iOS once it's determined where it needs to load, and then it goes through the configuration process where it locates the configuration file, typically from NVRAM or a TFTP server, or it has to be go through the console. Now, the thing about this is that you need to know these orders in order for you to understand how this whole process work and answer these type of questions. And the only way you can do this is just, if you don't understand how the process works, just memorize it. It'll get you to what you want, right? Get you the question. So that's everything for today. And if you have any questions or concerns about any of the questions that I have covered, please go back and watch my CCNA 1 Introduction to Networks lecture series. It explains much more detail all of these concepts. I know that I went more than 1 hour in this video, but I didn't explain everything in depth. So if you want to learn more, please go and check the CCNA 1 Cisco Introduction to Network. I also have the CCNA 2 and CCNA 3 lectures posted on my YouTube channel. Please go ahead and check that. In addition to that, I also have posted our module 1 to 3 exam revisions, as well as module 4 to 7 exam revision, also, you could call it review questions. So that's everything. If you like my videos, please make sure to thumbs up these type of videos and subscribe to my channel. And until next time, thank you so much and have a nice day.